spent a lot of time talking about graphing lines and graphing parabolas, but in this video I wanted to talk about how we can graph higher degree polynomials. So just a reminder, a polynomial is a function that has x, or any variable, but raised to a power, and that power is a whole number. It's not negative, it's not a fraction, it's not a decimal, and there can be a bunch of these added together with like a number at the end, but all of those powers have to be whole numbers, positive numbers, no fractions. Okay, so that's a polynomial. Now, by higher degree, I mean instead of focusing on lines like x to the first or parabolas x squared, I want to talk about higher powers than that. Now, the first thing to kind of note is that the highest power in a polynomial dictates the overall shape. For example, if I said x to the fourth plus 3x cubed minus 2x squared plus 7x minus 3, all of these terms kind of tell me what's happening in the middle, and they help me figure out, what kind of thing is happening in this graph. But it is this right here, the highest degree, that tells me the shape. Okay, so the highest power will always give me shape. And what I mean by that is an x to the fourth looks something like this at the ends. It almost looks like a parabola. But what happens in the middle can be all different types of things like that, based on those other terms that come after x to the fourth. So we've got all these little things that can happen in the middle, but the overall shape is almost going to be like a W-type shape. And when I say end behavior, what end behavior refers to is what's happening at the ends. Well, at this end, we're going to up toward positive infinity, and at this end, we're going up to positive infinity. So let's start by talking about odd and even highest powers. So if x, and again, this is all about the highest power, if the highest power is even, x squared, x to the fourth, x to the sixth, the end behavior will be like this. It'll be going to infinity, pointing towards positive infinity at the ends. And again, lots of things can happen in the middle, but we know that at the end, it's going up towards infinity, up, positive infinity in both directions. Now, I should mention, when we talk about just x squared, that, of course, just does this. It's a parabola. X to the fourth looks almost like a W shape. X to the sixth would add another loop. Every power higher adds another kind of like loop here, or up and down motion, I should say, in the middle. So the higher the power is, the more happens down here. Especially, again, when you add other terms. Nothing that, if it's just x to the eighth, it just kind of comes down, flattens out, and goes back up. But if you add other terms, that's how you get this kind of bouncing up and down in the middle. So x to an odd power looks something like this. So you can see that on one side, on the positive side, it is going up to infinity, but then over here it's going down to negative infinity. So that's its end behavior. So evens both go up, odd, going positive, it's going up to infinity, going negative, it's going down to negative infinity. And again, the more power you kind of add, the higher power. So like x cubed, we know, just kind of does this, but x to the fifth would go, that. And x to the seventh, like that. So every higher power will add more of the bouncing in the middle, but it's not going to change the overall end behavior. Now, one thing we should just mention here is we can always flip these. If I were to put like a negative, let me do this in red. If I were to do a negative in front, it would then flip it or reflect it like that. So if it was negative x to the fourth or negative x to the sixth, it would flip that end behavior, reflect it. And if I were to put a negative here, of course that would flip it like that. Now I'm going to get rid of those for just a second because I want to kind of formalize those ideas of an end behavior. We often do this with what's called a limit, and we say if x is just going bigger and bigger and bigger, okay, this just means I'm just plugging in larger and larger values for x. I'm going out this way, positive. What happens? Well, my function just keeps growing, positive. Whereas this one, if I just keep plugging in bigger and bigger negative values, I'm also going to positive infinity. Over here, if I plug in bigger and bigger positive numbers, it's going up to infinity. But over here, if I'm plugging in bigger and bigger negative numbers, I'm going down to negative infinity, like that. So that's called the end behavior. So I would just be really careful, always find the highest power first, figure out the degree of the polynomial. Degree is simply what is the highest power. And then that helps us figure out the shape. We right away know, okay, it's x to the 22nd. I know it's going to go up. It's going to go up. There's going to be all these kinds of bounces in the middle because I just made up x to the 22nd. But we know the overall shape. If it was x to the 31st, if that was the highest power, I know this. I know that it's going to have that. Then it's going to have all these little bounces in the middle dictated by the other terms. Okay, but the highest powered term tells us the overall shape and what's kind of happening. We can kind of almost think about like we have this blank box in the middle that the other terms tell us what's happening, but the biggest one tells us what's happening at the ends. If this video helped you, please like and subscribe for more math help.